Hey, welcome back to the HFSS video series, and we'll be dealing with the Optimetrics, that is the sweeps that we want to set up. What I'll be dealing with is the substrate height, how exactly the substrate height would affect my antenna. And to begin with, what we have to do is we need to set up variables, and then we have to go to the Optimetric section and set up the sweep such that we have a starting point and an end point with a step size, and then we leave it as is and things will happen. All right, so to start off, what you need to do is you want to go ahead and select the substrate, whatever element that you want to change. In this case, I'm going with the substrate as an example. So you go to create box, and I'm going to convert this 1.6 into a variable, which all you have to do is hit dollar and then a variable. So in my case, I'm going to call it as sub h, which is the substrate height. And the moment you do that, you get this particular box. Of course, I'm going to hit OK. Ensure that the units are matching what you've been doing so far. Right, so that should do it. That is the only thing you have to do. You just have to convert the fixed value into a variable. Now, once you've done that, you need to come to Optimetrics to the left hand side, right click, add and parametric. If not, you can always go ahead and come to simulation up top and Optimetrics parametric. Right, that is the way we're going to go ahead and run the sweep. Now, when you're going to go ahead with the sweep, you need to first add sweep definition. So add, and I'm going to add the substrate height. So I'm going to go from 0.5 to 3.2 with a substrate, or rather the step size of 0.01. And the moment you add this, you will see that a sweep has been generated from 0.5 to 3.2 with a step size of that. Now this is it. This is all that we wanted to do. If you check the table, we have around 271. Now this is going to take a long time, so I'm going to go ahead and make this 0.01 to maybe 0.1, so we can have lesser value. So 28 values, much more possible, like can be dealt with very quickly, right? So hit OK. Now that we've set that up, from now on, whatever analysis you would do, it would run this setup. So you have to ensure that if you don't want this setup, you have to disable it, or best case delete it. In our case, since we have it enabled, things will change in terms of results, but we'll get to that eventually. Right, so let's click on analyze all, and what I would want you to see next is this show progress. And if you notice, it is going to start running the state in which it is currently, which is at 1.6. It's going to run that default first, and it's going to give you results out here. Now once it's done, which I hope it does very quickly, we won't need these plots, so I'm going to get rid of them. I'm just going to work with these 4 for now. Okay, so what you would want to see is the S parameter VSWR gain. It's done, right? So if you notice now, this is how things are looking like in the default case. You have a VSWR of 2.4, or at 1.6, the gain is 3.9, and here the sweep is running at somewhere around 4 as far as I remember. Now this would multiply, right? Again, you would have a bunch of these guys coming in for other changes that you're going to make. So what we are going to do is we are going to set this up properly again, wherein we are now allowing the sweep results to be shown, right? So all you have to do is modify report, right? You will get this box, click on families, and instead of nominal, you want to select on all values, use them all. And as soon as you apply trace, you would see a lot more values have shown up, right? And this would go on for a while because it is calculating for a bunch of them, right? So far it has solved 4, now 5, and we'll get rid of this. Since we are concentrating on 2.4 gigahertz, I'm going to add an X marker. I'm going to keep it at 2.4. Right, so it is somewhere here. So what you notice is that there are other values sitting at minus 0.04. They are tipping elsewhere. They are tipping at much higher frequencies. So this is giving you results at those values. So if you see to the right, you have sub H. So you click on them, you will see at 0.05 or rather at 0.5, what is the value that it is going at 0.6. How's the graph looking like? Somewhere around 3.8 to 3.96. Right. So as you increase, you see that the frequency is slowly coming back. Right. And again, it moves away. So again, you cannot really predict at all times. We want to do the same thing here. So modify families and click on all and apply trace. So you get this. Oh, lot of high values. 121, 178, 203, 218. So these are not values that we would be interested in. Right. Similarly, gain. Now this plot you wouldn't be able to change. Right. You're not able to see multiple views at the same time. So this is one of those plots which you basically gather such data like this, and then only will you be able to understand what is the best case for you and how it would look like. So what you want to do is come to the second rectangular plot and modify report. What we want to do is have all values. Now if I do this, it's going to crash, I know. So I'm just going to quickly go ahead and add max in front of it, which would take the max value of all these angles, and only then will it show up. Now in this case, it's going to take us a while to get the sweep data because we've missed out on the initial values, but that's okay. We can always come back to it. As of now though, we are getting okay gains. I hope this does change. We have one at 3 point something. So we just have to wait at this point. We just have to let this sweep happen, and only then can we come back to this. But if you notice, there are indeed cases where as your height is increasing, your sort of frequency, the resonant frequency is coming back. It's going to the left a lot. And this is where your study plays a role, wherein what exactly is the height of your substrate, why you're going for it. These sort of results would prove that to you, like, okay, this is the reason why I'm going for it. This proves that based on simulations, we have chosen a certain substrate height. This was just an example though. Where we would be using this is in MIMO. Right, so I'm going to let this run, let this sweep complete, and then we're going to get back to the results and how exactly it turns out to be. All right, so now that the sweep has ended, we sort of get to see how many different values we got at 2.4, and rather at this stage you can pretty much see that 1.6 was the only one which gave us a good dip at 2.4 gigahertz, which was our frequency of choice. There are definitely other cases wherein you could see that maybe the bandwidth is much more, or anything along those lines, wherein if at all you want to get into that, then yeah, the choice is all yours. But this was just a simple example of how the data would be collected. Now if you can see VSWR, the least value we had was 1.68, but you also had values of 2.39, 3.06, close to like 1.8. I would assume this would be 1.7. Yeah. Right. So different values. Now in this case, the gain has remained pretty much straight lines, which is weird. I've never seen this like this. But what case gives you the highest gain, like 1.6? Right. So other cases, it sort of dips down. So then based on these results, what's giving you the highest value, you get to then come to modify report and then choose what you want to choose. Like if you choose one, and then you'll have to update, you'll have to analyze, and you'll have to go through that procedure again. and eventually you would come up with the gain plot. Now sometimes what will happen is it wouldn't show, so you'd have to come here, clean up solutions, you would have to do the deletions, but do that only after you've selected the best case. In this case, this was just a single variable parametric sweep. I think that's basically going to be the title of this video. And from here, we are going to move towards MIMO. We're going to move towards 2-port MIMO, 4-port MIMO. And like, I'm going to give you a basic idea of how you do it. And then, the choice is all yours of how you want to go about with it. But with this kind of structure, we're going to proceed with our results. We're going to proceed with our VSWR gain, whatever results that you would want to focus on. And from there, we're going to see if there are improvements when we do MIMO, when we do, we want to concentrate on gain as well as bandwidth. Now, in this case, the single element is giving a gain of around, what is it at? Let's add, it's 3 point something, right? It remains constant. 3.9380, so somewhere close to 4. It's not 4 as such, but it's close to 4. This data has been last adaptive, of course, it's not sweep. So that being said, I think now we can move towards the MIMO section, wherein we'll talk about how to set it up, what we need to do, and how we're going to do it, of course. And from there on, we shall proceed towards more complex results analysis, more complex understanding of how you go about with MIMO, what results mean to us, and so on and so forth, right? So next video onwards we'll be focusing on MIMO, and it will be built up on what we have done so far. Okay, so we're going to use the same patch, we're going to use the same Optimetrics structures, of course not the exact same. I'll be changing this back to 1.6 where it belongs, and then from there we're going to build up, right? So with that being said, this is it for Optimetrics. I hope you've gotten a clear understanding of how exactly variables are going to play a role in our MIMO journey, right? See you there.